Students, if you search your books, maybe it is intermediate or your foundation books or the JE books in physics, you will find a lesson, units and measurements. In my view, it is very important to understand what are the units and dimensions. Actually, this chapter will take you into the physical world. This chapter take you into the physical world where you will get numerous physical quantities. Where you get numerous physical quantities. Here, what is the physical quantity? The simple answer is anything which can be measured is a physical quantity, students. Anything which can be measured is the physical quantity. Often in daily life, we come across with these kind of physical quantities. Maybe the length of the table, maybe the length of your pen, maybe your mass, maybe here the time elapsed. Okay, these are all the physical quantities. Can you answer me, students? If you are suffering from fever, is the fever is a physical quantity? Is the fever is a physical quantity? And often we smile, we show anger on the people. Are they the physical quantities? They are not at all. You cannot measure the level of happiness or level of anger and level of fever. Fever is not the physical quantity, students. It cannot be measured, but the temperature can be measured. Okay, students, the temperature can be measured. Every time I am using the word measure here, okay, students, I told you what is the physical quantity right now. Anything which can be measured is a physical quantity. And we have to know what is the measure is. Okay, students, what is the measure? What is the measure? Okay, students, simply we can define the measure like this. It is a comparison standard. Okay, it's a comparison standard. Or simply we can say measure is the comparison with a reference standard. Comparison with a reference standard. See the students. What is the measure? Measurement. I'm telling you what is the measurement. Okay, students. What I said, it is a comparison with a reference standard. It is a comparison with a reference standard. How the standard will take? Now, students, just think I don't have any measuring scale with me. Right now, I don't have. But I have this pen with me. I have to measure the length of the board. I have to measure the length of the board. Here, it is the length. I started measuring the length. Okay, here it is the one length, the second, third, fourth, fifth, sixth. Like that, I will get on measuring around 15 or 16 length, students. Okay, then what is the length of the board? Here I took the measuring standard as this pen. Pen is the reference standard it is. What is here? Pen is the reference standard. Okay, students. And how many times I measured with this pen? It is 15. Here, what is 15 here? It is a numerical. 15 is a numerical. Okay, students. And here, reference standard is what? Pen. And what is the length of the board? What is, if someone asks you, what is the length of board? Simply I will write, it is 15 times 2. Okay, measuring standard. I have to say 15 pen. The length of the board is 15 pen. But it's not 15 into pens. Okay, students. Here, I'm not taking the plural of the pen, but I'm taking it as 15 multiplied with the pen. Here, 15 times. I measured the length with the pen. Here, pen is the reference standard. This reference standard is known as the unit. Okay, students. This reference standard is known as the unit. That's why I told you the first lesson, what you have to learn is units and measurements. The name of the lesson is units and measurements. Getting me, students? Okay, students, I told you here we have to take a reference standard and multiply with the numerical, and we got the length of the board. What is the length of the board here? It is the magnitude. What is the length of the board? It is the magnitude of physical quantity. Okay, what is this magnitude? How will you get? Here it is the numerical value. I am taking it as the n and multiplying with. Okay, students. Here n is the numerical value and I am multiplying with this unit. Okay, students. Then we can write magnitude of the physical quantity is equal to n into u. Okay, students. Then maybe a question arises within you. Maybe you are thinking that who will decide this reference standards? Who will decide this reference standard? If someone asks me, what is this width or the length of the board? Simply I say, it is 15 times 2 this pen. Here it is not a thing which is universally adopted. Okay, students. That's why we have a Bureau of Standards. Bureau of Standards and Measures located in England, where they decide the reference standards which are applicable universally. If you go anywhere in the world, okay, most of us know that the length is measured in meter or centimeter or millimeter or kilometer. Anywhere you go across the world, you will find the length is measured in meter, centimeter, okay, or millimeter. Okay, students. If I ask you, what is the measure of the length? Simply we'll say, as someone said, it is centimeter. It's right. Everyone knows that. As someone told, it is the meter. It's also right. If someone told, it is the millimeter or micrometer or kilometer. These are all the things which are adopted by the universe. Okay, students. This reference standards will be decided by the Bureau of Weights and Measures, students. Okay, students. Okay, students, right now we are going to learn about what the characteristics a unit must have. What are the characteristics the unit must have? What is a unit, students? Unit is nothing but a measure of a physical quantity. I told you what is the measurement. It is a comparison with a reference standard. Here I took the pen. It is my reference standard. But it is not accepted by the international community. Okay, we only get international. Okay, students, not accepted by the international community. What's that? It is accepted when it has few characteristics with it. Like the first one is invariability. First one is invariability. That means what? It should not change from one place to another. If you measure 1 meter here in your own town, it has to be same if you leave the another town or another country or another planet. What I mean, there should not be any variation if you measure anything international or anywhere in the universe. Unit must have the invariability, students. Okay, and the second one, it must have international acceptance. International acceptance, students. That means what? Every community in the world must adopt this one. Okay, this should be adopted by every community in the world, any country. Okay, the third one and most important one, students. What is this? Availability. The third one is availability. That means what? It should be available very easily anywhere across the world. Okay, students, that is the measurement, and you learn that what is the physical quantities and what is the unities. What is the physical quantity, students? Anything which can be measured is a physical quantity. And what is the measurement? It is a comparison with a reference standard. Okay, students. And third, what is the unit? Unit is the measure of a physical quantity. Okay, students. Right now we are talking about the units. Most of you know about the physical quantities which are around us. The first such physical quantity you can take is length. Length is a physical quantity, students. In the same way, mass is one more physical quantity. And third is the time. Time is one more physical quantity, students. We have different physical quantities which are around us. Majorly, we know these physical quantities. These physical quantities are always along with us. Length. Maybe you can measure your height. It's nothing but the length. Physical quantities. Okay. Solid angle is measured in radians, students. Plane angle is measured in radians. And solid angle is measured in steradian, students. And we symbolize it as plane angle, radian, RD, steradian as well. Okay. In next video, we are going to learn about What is that? What is meant by a fundamental physical quantity? And what is the derived physical quantity? And what is the difference between these? Okay, students. Thank you for watching my video. If you like my video, please subscribe my channel and forward to your friends and your brothers and sisters students. What mass you have? Maybe someone told 35 kg or 50 kg is the mass. At the time, what is the age of you? Maybe 10 years or 15 years or 20 years. Okay, students, these are the physical quantities. And we have plenty of physical quantities around us. Okay, like see, velocity. Velocity is a physical quantity. And fifth, acceleration. It is one more physical quantity. And we have work. Okay, it is a physical quantity. And force, I measured the order, students. I have to write force, then after is the work. Okay, and you know all these physical quantities which are around us, pressure and so on. These are all the physical quantities. If it is a physical quantity, we learn that it must have a measurement, and this measurement is nothing but reference standard. Okay, we have three different reference standards to measure the physical quantity, students. Okay, students, we have the three different reference standards to measure the physical quantity, students. It all happened till 1972, I think. Okay, we used three different standards or reference standards to measure the physical quantities. One such standard is known as CGS, students. Or simply we can say CGS system of unit. It is a CGS system of unit. Okay, the second one is the MK, students. And the third one, okay, it is the FPS unit, students. Okay, till 1972, the entire world used these three types of system of units to measure the physical quantities. Here, the CGS is actually French system, and it is named after Mr. Gauss, and we call it as the Gaussian system. Gauss is a very famous scientist in electricity, students. Okay, in previous coming years, in future, you will learn about the Gaussian surfaces in electricity, students. That's why the system is named after Mr. Gauss. Okay, the second is a metric system. And the third one, it is the British system, students. Okay, students, if you are good in history, you may learn that our country is ruled by British for more than 200 years. In such way, it ruled so many countries around the world. They adopted, the countries which are ruled by the British adopted the system, students. We call it as the FPS system unit. Here in this one, F stands for food, students. P is pound, and S is second. And these three are the measuring standards. Foot means what? Length. Okay, students, pound, it is the mass. And the third one is time. These three are the measuring standards. Okay, physical quantities. Then the measuring standards are these. Reference standards. These are foot, pound, and second. In the same way, if you go with the metric, we come across with the three. Okay, students, in metric system, We have the three. Third day, M stands for M. It is the length. The second one, K, here, it is the mass. And yes, it indicates the time. And what is the measure standard or reference standard? The reference standard is length is measured in meter. Mass is measured in kilogram. And time is measured in second. Okay, students. These are the reference standards in MK system. And what is the third one? Actually, it's the first one. We said it is the CGS. CGS. C stands for centimeter. G stands for grams. M, yes, for second, students. And it represents the length, students. It is mass. And third is second. If you observe these three different types of system of units, you will find the second is the physical quantity, which is involved in all and which has the same unit. There's second, second, and second. These are the system of units till 1972, students. Then after, a new system of unit is introduced. We call it as the SI system, students. It is the CGS. Okay, Gaussian system. The second is metric system. And third is British system. Okay, students. Then after, a rapid growth is happened in the field of science and technology in 70s, students. And before that only, many new physical quantities are invented. Okay, many physical units we came to know, students. That's why a new system is developed. Actually, we are in need of finding a new system of unit to measure all the physical quantities which are discovered later, students. The system is known as the SI system of units, students. It is SI system. Okay, in English, this SI system is called as international system, students. International system. And in French, it is called as System de International. System de International. Okay, students. Maybe this one is familiar to you, isn't it? When you are studying the history, maybe you came across with the word Vasco da Gama. The same thing is happening here. It is a French word, student, System de International. And you have to ask me, what is the difference between these three systems with the System de International? If it was these three systems, CGS, MKS, and FPS, primarily we have only three physical quantities. It is the mass, length, and time. Here also you will get mass, length, and time. And here we got the mass, length, and time. But SI system of unit has more physical quantities than these three systems. The fundamental physical quantities, what is that? Is the mass, length, and time. Yes, students. Then, after the discoveries and scientific advancement, more physical quantities are discovered, and some more applications also happen, students. If you go with the SI system, instead of three physical quantities in those three or the systems, we have more, students. They are like this. One is the mass, second is length, and third is the time. These are a standard. Additional to that, one more physical quantity is discovered. It is electric current, students. Electric current. The next one is luminous intensity, students. And the sixth one is quantity of matter, is the one more physical quantity. See this? Mass, length, time. Generally, we have these three, and additional to that, electric current being added, and luminous intensity, and quantity of matter, and finally, one more physical quantity is added. It is known as thermodynamic temperature. Okay, students. It is thermodynamic temperature is one more physical quantity which is discovered. If these are the physical quantities, then we must have a reference standard, isn't it, students? A reference standard is nothing but the unit. Here in this system, mass is measured in kilograms, students. Generally, we call it as kg. Okay, students, it is a unit. And length, it is measured in meter and abbreviated as m. And the third, time is universal. It is measured as second in every system. And electric current, it is measured as ampere, students. Electric current is measured as ampere and symbolized as A. You have to remember one thing, students. When a physical quantity is named after a scientist, or its unit is named after the scientist. Okay, here ampere is a scientist, students. When you are writing the unit fully, you have to start with the small letter only. Remember this, students. We have to write the name of the scientist with the small letters only, ampere. If you are representing with the symbol, you have to go with the, what's that, capital letter. Okay, students. If you are writing name of a scientist as Om, okay, here it is. Or any Weber. Okay, writing the name, you have to start with the small letter. And you have to write the symbol with the capital, students. Remember this. And luminous intensity. It is the intensity of the light, students. Luminous means what? Intensity of the light. Okay. This intensity is measured in candela, students. Candela. And it is shown as C. And quantity of matter. You know this? It is measured in mole. And you have to write it as mole only. And finally, thermodynamic temperature. It's also named after a scientist. His name is Mr. Kelvin. Kelvin. Okay, we have to write it as capital K. These are the fundamental physical quantities. I didn't, what's that? Explain to you what is the types of physical quantities actually. Okay, here these are the physical quantities, and these physical quantities are named as fundamental physical quantities, students. Here, why they are fundamental physical quantities? And what is the use of knowing about the physical quantities? Is there any other type of physical quantities? These things will be explained in the next video, students. We'll go with the fundamental physical quantities and as well as the derived physical quantities. Actually, these are the fundamental physical quantities in SI system. Additional to these 7, we have 2 more physical quantities, students. One is the plane angle. The second is solid angle, students. These 2 are known as supplementary physical quantities. Physical quantities. Okay, solid angle is measured in radians, students. Plane angle is measured in radians. And solid angle is measured in steradian, students. And we symbolize it as plane angle, radian, RD, steradian, SR. Okay, in next video, we are going to learn about what is meant by a fundamental physical quantity and what is the derived physical quantity and what is the difference between these. Okay, students, thank you for watching my video. If you like my video, please subscribe my channel and forward to your friends and your brothers and sisters, students. There are 2 types of physical quantities. One is the fundamental physical quantities, and we name them as what? Mass is a fundamental physical quantity. Okay, students, and the length is one more fundamental physical quantity, and third, time is one more, and we are writing about the SI system of units here. Then after, I said it is thermodynamic temperature, and the next one is quantity of matter, and luminous intensity, electric current. I said these are the fundamental physical quantities in SI system. Additional to that, we have 2 more. They are supplementary physical quantities. Here in supplementary, we have 2. One is plane angle and the second one is the solid angle. In previous video, we learned up to here. Okay, students. Today we will learn about how to write the dimensional formula. First of all, we have to understand what is the dimensional formula is. A dimensional formula explains us which physical quantities are involved in it and how they are arranged. A dimensional formula tells us which physical quantities are involved in that formula and how they are arranged. How we'll write the dimensional formula? Basically, we will take these fundamental physical quantities to write the dimensional formula. Most of the physical quantities have the mass, length and time terms. Additional to that, thermodynamic or quantity matter. Anything can be added with. Okay, students. First I am taking the first letters of 3. These are the base units, base physical quantity students. I'm writing it as M, L, and T. Okay, students. M, L, T. Okay, it is mass, is the length, and it is the time. And we have to learn how we have to arrange these physical quantities to get a dimension formula. Okay, students. First, we are taking the length. Okay, students. What is length? Okay, it's a measure between the 2 points. We are taking length. The length can be written as like the students. Length is written as L power 1. In the same way, we have to write the mass. Mass can be written as M power 1. Okay, students. And time is T power 1. I'm writing the same here. Now I put the powers. These powers are known as the dimension, students. Okay, students. What are these powers? Powers are known as the dimensions. What is the dimension? Okay, the power to which the fundamental physical quantity is raised. Dimension means the power to which the fundamental physical quantity is raised. Okay, students. Power means what? Sorry, dimension means what? Dimension means the power to which the fundamental physical quantity is raised. If you have the time, please note these definitions, students. Okay, what is meant by the dimension? Dimension means the power to which the fundamental physical quantity is raised. We learn that physical quantity. What is the physical quantity you have learned? And what is the fundamental physical quantity? Any physical quantity which doesn't depends upon other physical quantity is known as the fundamental physical quantity, students. A physical quantity which doesn't depends upon any other physical quantity means what? It has its individualness with it. It has its individuality. For example, you take the mass. Mass is a fundamental physical quantity, students. Means mass doesn't depends upon any other physical quantity like length and as well as the time or the thermodynamic temperature or any other. What does it mean? The mass remains constant everywhere. Mass doesn't depends upon any other. It doesn't depends upon time. If 1 kg mass we kept somewhere, it will be 1 kg only for coming hundreds years, hundred of years, or thousand of years, or 1 month, or 1 day. It doesn't change by own. And the second thing, time is also a fundamental physical quantity. It doesn't change. You can't get the time 8 o'clock here, where you are listening the lesson, or somewhere it might be 9. It doesn't. In the same way, length. If I am a height of 5'7" here, I should be 5'7" at anywhere. Okay, students. It doesn't depends upon any. If a thing becomes big, the length of the thing doesn't change. Okay, students. That's why we call it as a fundamental physical quantity. Here, what is the dimension? The power to which the fundamental physical quantity is raised. Okay, students. That means what? Mass is written as, I wrote it as m power 1. M power 1. This is the dimension. This is the dimension. Okay, students. And this one is the physical quantity. physical quantity. Are you understanding, students? Okay, students. M is physical quantity, its power is dimension. If it is written as m square, for example, again, the square is the dimension and m is the physical quantity. For example, you take the length, L power 1. This 1 is the dimension and L is the physical quantity. If you write it as the L square, 2 is the dimension and L is the physical quantity. I think you are understanding what is the power is. Okay, the power is nothing but the dimension, students. Dimensions are the powers to which the fundamental physical quantities are arranged in. I hope you understood. Okay, students. If someone asks you to write the dimensional formula of mass, okay, students, basically we involve all the physical quantities to write a dimensional formula. I mean, the base units are what? Base physical quantities, mass, length, and time. Okay, I am writing the dimensional formula for mass, students. Dimensional formula. Shortly, I am writing it as DF. I told you dimensional formula is the which explains which physical quantities are involved in it and how they are arranged. How they are arranged means the powers. How the powers being arranged. Okay, students. I am writing the dimensional formula of mass. Okay, mass. I am taking the first letter M. This power is 1. Okay, next I am taking L and T. Generally, we represent a dimensional formula with all the base physical quantities, M, L, T. Is there any length in the mass? No. It doesn't depend upon length. Mass is mass only. We can't say only 10 centimeter of mass. Length has the mass. Okay, anything has the mass. In the same way, I already discussed the time. With time, the mass of the body doesn't change. If you keep 1 kg of sugar here, it could be 1 kg for coming years if no one touch it. Isn't it, student? It is the dimensional formula. It is the dimensional formula. See, students, in the same way, we are writing the dimensional formula of length. Okay, students, how we will write? The same trick we have to write M, L, and T. This time, mass is 0, length is 1, and time is 0. Okay, students. And similarly, dimension formula of time. We have to choose all the physical quantities here, M, L, T. Then we have to put the powers. M, 0, L, 0, and T is 1. Maybe in examination it will ask you, what are the dimensions of mass, length, and time in the dimensional formula of time? What are the dimensions of mass, length, and time in the dimensional formula of time? Simply have to write. Mass has the dimensions of 0, length has the dimensions of 0, and time has the dimensions of 1. Okay, students. The same could happen here. The dimensions of mass is 0, length is 1, and time is 0. Here also 1, 0, 0. In that way, we will write the dimensions. Let's go with few more dimensions here, students. Okay, students, I hope you are understanding. If you listen to the class, further you will understand how to write the dimensional formula and what is the dimensional equation and what are dimensions also. Okay, students, we are writing a list of dimensional formulas. First we start. Already we learned about the length. Okay, students, if it is the length, we wrote the dimensional formula as M0, L1, T0. Okay, students, and we mentioned the dimensions as 0, 1, 0. These are the dimensions. Okay, students, then we take the mass. Mass, you know that. M power 1, L0, T0 means what? What are the dimensions here? M1, comma 0, and 0. Then we take the time. Time can be written as what? M0, L0, and T1. And the dimensions are 0, comma 0, comma 1. I think you are understanding now, students. Now we'll write the dimensional formula of one more physical quantity. Here I am writing the dimensional formula of area. Okay, students. Area is a derived physical quantity, students. Now listen my words carefully. I said fundamental physical quantity is a quantity which doesn't depend upon any other quantity. It is individual. Okay, it is individual. And what is the derived physical quantity? The physical quantity which depends upon other physical quantities. Derived physical quantity means what? Derived physical quantity okay, what is the derived physical quantity? The physical quantity I am writing shortly, which depends upon other physical quantities. Let's see how it is. Okay, area. What is meant by area, students? See, I'm taking a square now. Take it as a square. Okay, square means what? Okay, it is the length and breadth. Okay, here, if it is a square, it is the square. You learn that in case of square, length is equal to breadth. Is it? And we can write the area of square. Area of square A is equal to length into breadth. Okay, students. Here I said length is equal to breadth. Then it can be written as L into L. That is L square. Okay, students. No mass is involved in it. No time is involved in it. Only length is involved. Now we are writing the dimensional formula. Okay, students. I said symbolically we represent three physical quantities in a dimensional formula. That means what? We have to take mass, length, and time. See the students. Mass, this area, is not at all depends upon the mass. That's why we are writing the power. That is dimension is 0. And length is c. Length is of 2 times. That is square. And time is 0. Okay. It is the dimensional formula of area, students. See, M0, L2, T0. And what are the dimensions? Watch it. 0, comma 2, comma 0. It is about the square, students. Now we are taking a circle. Okay, I'm taking a circle. It is a circle. And you know that circle has the radius and the area of circle, the length, area of circle is pi into r square. Here radius, r is the radius, students. Radius is is length only, isn't it, students? Then you can write radius or as L and okay, students. Now we have to write the dimensional formula. Here you have to ask me, it has the pi, where you left the pi cell. I didn't left. Pi is a constant, students. Pi is a constant. Pi is a constant. Constants and numbers, that whatever the number is, 3, so on. It is a number. Don't have any dimensional formulas. Okay, students. Is constants and numbers. Not all the constants, few constants. Don't have any dimensions. That's why we are neglecting the pi, since it is a constant. Then what we got here? Area of the circle can be written as pi r square. Pi r square means what? It has only length. Then again, we'll write the dimension formula. Dimension formula is what? Length into breadth. Here we have the r square. R is nothing but L, that is L square. And the dimensional formula is m0, L2, T0. And the dimensions 0, 2, 0. Compare with the students. Area, whatever the area is, what is what's that? Area of the circular patch, or a square, or a rectangle. For example, you take the rectangle. Okay, it is the length, and the breadth. Obviously, length is length only, and breadth is the length. We get the same thing. Understanding, students? I hope you understood how to write the dimensional formula of a derived physical quantity. Let's go with one more, students. Okay, we are getting the dimensional formula of volume. What is volume, students? You learn that volume is nothing but length into breadth into height. Volume means what? Length multiplied with the breadth and height, students. Okay, then the dimensional formula of volume can be written as, here we have to take the m to the power of 0, L. If L is equal to B is equal to H, you can write it as L cube. I'm writing it as L cube. The time is 0. Okay, students. And what are the dimensions? Dimensions are 0, 3, 0. Maybe the question will be asked like this. What are the dimensions of length in the dimensional formula of volume? What is the dimensional formula of volume? M0, L0, T0. What are the dimensions of length? Obviously it is 3. What is the dimension? Power to which the fundamental physical quantity is raised. Now let's do one more. Already we found the dimensional formula of length. Okay. Length is what? M0, L0, T0. Okay. Mass as M1, L0, T0. Time as M0, L0, T1. Okay, students. And we got the dimensional formula of area. Area we had it as M0, L2, T0, and volume. Volume is M0, L3, T0. If you want to note these, students, please freeze the frame and you can write the dimensional formulas. Okay, students. Next we are writing the dimensional formula of one more derived physical quantity. Okay, before that we will write the dimensional formula of displacement. Dimensional formula of displacement. And you have learned that displacement is the shortest distance between the 2 points. Let's say it is the path, say it is A and it is the B. Then this one is displacement, shortest measured length between the 2 points. It's nothing but the length, students. But displacement is a vector. Displacement is a vector. And in next videos, you will learn about the vector physical quantities. If you are eager to know about the vectors, go to my channel. You will get around 14 videos about the vectors and students. Here, most of the topics are covered in those videos. If you like, please go through. Okay, students, it is the displacement. We are writing the dimension formula. Displacement is nothing but length, I said. What's the dimension formula? That is m0, L1, T0. Displacement is nothing but length. That's why I got. In the same way, the length. Length means what? The measured length between the 2 points. Okay, it is the distance, students. Here we are writing the dimension formula of distance. Distance do have the same dimension formula since both are lengths. That is m0, L1, T0. Okay, students, we covered the displacement. Then the next physical quantity, which is a derived one, and you know about this, that is velocity. What is the mathematical relation for the velocity, students? Actually, velocity is a derived physical quantity. Additional to that, it is a vector quantity, students. A vector quantity is always represented with arrow on head. Okay, students. If the V is a physical quantity, if you keep an arrow over the head, it represents a vector. Okay, velocity. How can we define velocity? Rate of displacement means what? Displacement upon time. Okay, students. Displacement is nothing but length. We have to write it as L upon T. Okay, students. And what is the dimensional formula? Dimensional formula can be written as L means L power 1 being taken up, then it is L inverse. To write the dimensional formula, generally we use the three physical quantities in mass, length and time. Here, mass, no mass in velocity. But length has the dimensions of 1 and time has dimensions of minus 1. See, till now, we went through the dimensions which are only zeros or the plus. Now, negative dimensions we are writing. We wrote the zero dimensions, then after the positive dimensions. Now, we wrote the negative dimensions. What are the dimensions? 0, comma 1, comma minus 1. Okay, students. Velocity is over. Then we go with acceleration. And you know that acceleration. Did you experience acceleration in your life, students? Generally, we go through the acceleration in daily life. Vehicles provided with accelerators. People generally call it as the accelerator, but it is the accelerator. What is the accelerator? It increases the speed of the vehicle, students. It increases the speed of the vehicle. Bikes do have the accelerators. Just think, for us, what are the accelerators for a human? Obviously, our legs. If we make the legs to run faster, we have greater acceleration and as well as the velocity. And if you start reducing your speed in given time, you are retarding. Okay, students, acceleration means what? Velocity upon time. Velocity upon time. Acceleration is shown with the letter A. It is another physical quantity which is a vector, students. Velocity by time. Okay, students. Velocity means what? Length upon time, already we wrote there, by time. That is length upon square of the time. Then you can write length t power minus 2. If you represent it as dimensional formula, we are involving mass also. That is m0, L1, t minus 2. Okay, students. Whatever the acceleration is, it is the acceleration, retardation, or acceleration due to gravity. it has the same dimensional formula. Just we have to add the word before. Acceleration due to gravity. Retardation. Okay, students. And what are the dimensions are here? 0, comma, 1, comma, minus 2, 6. We are getting the negative dimensions here. 0 dimensions, positive dimensions, and as well as the negative dimensions. Maybe the question will be asked like this, students. What are the dimensions of time in the dimensional formula of acceleration? Obviously, it is minus 2. Okay, students. Let's go with one more physical quantity. Okay, students. I hope you are understanding and you noted all these things. Okay, volume, and we got for velocity what we had. For velocity, we got it as m0, L1, T inverse, and acceleration. It is m0, L1, T inverse. Okay, students, I hope you understood how to write the dimensional formula till now. And I'm writing one more dimensional formula for a derived physical quantity. That is force. That is force. Force is one more vector quantity, students. Force is one more vector quantity. What is the force? Mathematically, we can treat the force as the product of mass and acceleration. Mathematically, we can write force as mass times to acceleration. Force means mass multiplied with the acceleration. But we have to define it as, okay, we have to define the force as force is that which changes or try to change the position of the body. Force is that which changes or try to change the position of the body. Simply we can say force is a mischievous thing. And what is its characteristic? If a body is resting, it tries to move the body. If the body is moving, it tries to stop the body. Understanding, students? We have to write the dimensional formula for force, students. Okay. The dimensional formula of force is what? Mass means you learn that m1, f0, t0. For acceleration, we are borrowing from here. It is m0, L1, t inverse 2. Okay, students. Then we can write the dimensional formula as these are the bases. If the bases are same, we have to add the powers. M to the power of 1 plus 0, L to the power of 0 plus 1, T to the power of 0 minus 2. 1 plus 0 is equal to 1, M1, L1, T inverse 2. It is the fastest way to write the dimensional formula, students. In other words, you can write the dimensional formula. Mass is m and acceleration is what? Velocity by time. Okay, students. Then you can write mass as m1, l0, t0 multiplied with velocity. Already we had m0, l1, t inverse 1 by m0, l0, t1. We are doing the same here. M to the power of 1, L to the power of 0, T to the power of 0, and to m to the power of 0, L power 1, T inverse 1. I am taking these up. It is m to the power of 0, okay, L to the power of 0, and T to the power of minus 1. Again, we are taking the same physical quantities which have the same base. That is what? M, it has a power of 1 plus 0 plus 0, L 0 plus 1 plus 0, T to the power of 0, okay, minus 1, minus 1. We get the same thing. M to the power of 1, L to the power of 1, and T to the power of minus 2. See, what we had here, the same can be, okay, found by using this relation. Force is over, students. Then after, we are going with one more physical quantity, which is work or energy. Okay, students. Now we are writing the dimensional formula of work. What is work? Force multiplied with the displacement, students. Force multiplied with displacement. It is a mathematical relation, students. Actually, you have to write or define the work like this. By the application of the force, if a body gets displaced, displacement means what? Has to move along a straight line. Then work is said to be done. By the application of the force, if a body gets displaced, the work is said to be done. That means force has to displace a body. Yeah, that's why I wrote force. Okay, multiplied with displacement. Okay, the dimensional formula of work is what? Force is mass into acceleration. Displacement means S. Mass means I am writing the dimensional formula. M1, L0, T0. For acceleration we are borrowing M0, L1, T inverse 2. Displacement is nothing but length. That is M0, L1, T0. We are doing again the same what we did before. M to the power of 1 plus 0 plus 0, L to the power of 0 plus 1 plus 1, T to the power of 0 minus 2 plus 0. And finally we read M to the power of 1, L2, T to the power of minus 2. Then see the powers. 0, 2, minus 2. These are the dimensions. Okay, students, it is the dimensional formula. And remember, students, work and energy have the same units and as well as dimensions. Wherever you will find the energy, its dimensional formula is M1, L2, T inverse 2. Okay, students, what type of energy it is? Okay, we should not worry about that. It is electrical energy, heat energy, sound energy, whatever energy. Okay, potential energy, kinetic energy. Anything has the same dimensional formula, students. This is the way to write the dimensional formulas. The two, I gave few physical quantities for you. We completed the work. Okay, acceleration. Then after we got for force, it is M1, L1, T inverse 2. Okay, students. And we got a numerous physical quantities there. Okay, understanding, students. I hope you are understanding. And we go with one more. Okay. Now we are writing the dimensional formula for few constant, students. Dimensional formulas of few constants. Some constants don't have dimensional formulas. I showed before. Okay. Numbers and as well as the few constants. For example, you take a equation, students. It is the equation for the energy, students. Energy is equal to H into nu. What is E here? E is energy, students. H is Planck's constant. You will learn about this thing in coming study, students. Planck's constant. And nu. Nu means frequency. Nu means frequency. What is the frequency? Reciprocal of time. Reciprocal of time period, students. And you know that time period or time are same. That means what? It is 1 by t. Okay, students, we have to write the dimensional formula. Energy. Okay, you learn that. H is equal to E by nu. We are writing the dimensional formula of constant. That is what? Planck constant. Okay, students. Here H is the Planck constant. You know that energy has a dimensional formula of what? Earlier we got that is M1, L2, T inverse 2. By frequency, I said it is 1 by 2. Take it up, you will get M1, L2, T inverse 2. Okay, it's going on. It becomes T. Okay, students. Then it can be written as M1, L2, T inverse 2 plus 1. And finally we can write it as M1, L2, T inverse. Say students, M1, L2, T inverse. Then the dimensions. What are the dimensions? 1, 2, comma, minus 1. Okay, students, now we are writing the dimensional formula for one more constant, students. That constant is known as universal gravitational constant. Universal gravitational constant. Okay, students. What is this universal gravitational constant? Generally, this constant is shown with the letter G, students. Okay, this universal gravitational constant explains about the force acting between the two bodies. Let's say it is the mass M1 and we had one more mass M2. They have been separated by a distance of d. Okay, students, I am joining the centers. Then a force acting between them along this line, students. This force depends upon the two factors, students. One is the mass of the body, directly proportional to mass of the bodies, and inversely proportional to the square of the distance between the centers. Then we can write it as 1 by d square. If we write together, we can write it as F is proportional to m1 m2 by d square, or F can be written as G into m1 m2 by d square. Okay, it is a formula for force acting between the two bodies. See, students, universal gravitational constant is useful to find the force between two bodies. That means in universe, every two bodies are attracting with each other. Every two bodies are attracting with each other. Here two masses we took. Maybe it is the sun or the earth or moon or you or me. Okay, students, these are the masses. They being separated by a distance of d. Then force is directly proportional to the product of their masses and inversely proportional to the square of the distance. Together, they can be written as like this. Okay, we have to write the dimension formula for G, students. G can be written as, okay, I'm multiplying this, F into d squared by m1 m2, where F is 4, students, and length, the dimension of formula of force is m1 L1 T inverse 2, already we derived, and d is what? Length, students. Okay, length means what? m0 L1 T0 and m1 m2. M is mass, students. Mass we derived m1 L0 T0. We have to put all these things here. That is, G can be written as F. We had it as m1 L1 T inverse 2 multiplied with, what is that length? m0 L1 T0, and it is squared, see this, upon m1 m2, m1 L0 T0 multiplied with m1 L0 T0. Further, it can be written as, students, m1 L1 T inverse 2 into m to the power of 0 into 2, that is 0, L squared T0 by m squared L0 T0. Further, it can be written as m1 L1 T inverse 2 multiplied with m0 L2 T0. I'm taking it up and it becomes m to the power of minus 2 into L to the power of 0 T to the power of 0. Then We are taking the bases. Here bases are same. We have to add the powers. M to the power of 1 plus 0 minus 2. L to the power of 1 plus 2 plus 0. T to the power of minus 2 plus 0. Okay, students. Plus 0. Then it can be written as M L to the power of 3, T to the power of minus 2, or M inverse LQ T inverse 2. M inverse LQ T inverse 2. Okay, students. And what are the dimensions? Minus 1, comma 3, and minus 2. Listen, students. This dimension formula has its own speciality. It is only one physical quantity in entire mechanics which has the negative dimensions of mass. Remember this. Universal gravitational constant is one and only physical quantity which has negative dimensions of mass. See, the mass dimensions of mass is minus 1. It is a very important question for the competitive section students. I hope you enjoyed the class. If you like my video, please forward to your friends and don't forget to subscribe it and go for a like. Okay, students, let's meet in next video. That could be the extension of this one. That means we will write some more dimensional formulas for different kinds of physical quantities. In previous class, you have learned about how to write a dimensional formula and what are meant by the dimensions. Once again, I repeat you, dimensional formula is the arrangement of physical quantities actually, and it tells us which physical quantities are involved in it and how they are arranged. It tells us which physical quantities are involved in it and how they are arranged. And the second one, the dimensions, the powers to which the physical quantities are raised. The powers to which the physical quantities are raised. For example, you take the dimensional formula of velocity. As you know that velocity is written as m0 L1 T inverse. Here the power of, what is that, m is 0. That means what? Dimensions of mass is 0. L1, the power is 1. 1 is the dimension, it is the dimension of the length. And T is negative dimension, that is minus 1. Here we will go further into the topic. See students, here I wrote 4 different things here. One is dimensional variables. Variable means what? Which is changing. For example, you take the area. Area is the variable. Okay, students, dimensional variable. Area is the variable. As you know that area, okay, it is one of the example. And also volume is the dimensional variable. I know that the dimensional formula of area is, we have it as m0 L2 T0. It is the dimensional formula of area. Okay, students. Similarly, we can take the volume, that is m0 L3 T0. It is dimensional formula of volume. See, the value of the L is changing. That's why I said it is the variable. Here, L has the powers of 2 and it changed to 3. In the same way, you can take the length and you can write it as m0, L1, T0, L value being changing here. Okay, I think you understood what is the dimensional variable. Second is dimensionless variables. Okay, few physical quantities don't have any dimensions. Okay, students, dimensionless variables. You can go with the strain. Strain is a dimensionless variable, students. What is the strain? Strain is change in length to original length. Okay, students, you can take Strain. Okay, students, what is the strain? Strain is change in length to, upon original or initial length. Okay, students. Change in length. Generally, we write it as delta L. Delta L is change in length by length. Okay, students. It also don't have any dimension formula. Okay. Change in length to original length. Then we see the third, dimensionless constants. Here, most of constants are dimensionless. For example, angular. Okay, students, and a numerical pi. Pi is a constant. As you know that the value of the pi is 3.14. Okay, the value of the pi is 3.14. It is a dimensionless constant. And the final one, dimensional constant. In previous class, we talked about these dimensional constants like universal gravitational constant. Universal gravitational constant. I told you it has a dimensional formula of m inverse L cube T inverse 2. It is one of the physical quantity. It has negative dimensions of the mass, students. In entire mechanics, we have only one physical quantity which has the negative dimensions of mass. It is a universal gravitational constant. In the same way, we talk about H. It is the universal gravitational constant, and it is Planck constant. Okay, students, and you know that it can be had by the equation E is equal to h nu, h is equal to E by nu is energy, m1 L2 T inverse 2 by 1 by T, that is m1 L2 T inverse. Okay, it is one more constant which has the dimensions. You will come across with so many constants in coming classes, students. And in the same way, if you go with dimensionless constants, we have one more, just I remember. It is the refractive index. Refractive index. Refractive index is the ratio of the sine of the angle of incidence to the sine of the angle of refraction, students. Okay, students, we are entering into another part of the units and measurement, students. The important one is dimensional analysis. Okay, what is the dimensional analysis is and how it is useful, we have to understand. We can analyze the dimensions in different ways, students. The first one is what? To convert one system of units into another. In dimensional analysis, we come across with few different types to understand the dimension, students. One is to convert one system of unit into another. Okay, students. Okay, students, it tells us how to convert one system of unit into another. Here, if I ask you one thing, what is the unit of the length? And I got few answers for that. One student said it is kilometer. Second is said it is a meter. And one told it is centimeter. And other told it is a millimeter. And I have to decide which is the right answer. Actually, 4 are the right answer, students. But the students expressed the unit of the length in different kinds of systems. One mentioned the practical unit, which is kilometer. The second one, MKS, that is the meter. The third one said it is the CGS, it is the gaseous system. And one set, it is a millimeter, is also subsystem of the CS students. Here we have to understand how to convert one system of unit into another. If one asks you, convert 100 centimeter into meter, simply your answer will be 1 meter, 1000 meter into kilometer. Okay, and simply we'll say it is 1 kilometer. And one said, convert 60 seconds into minutes. Obviously, the answer is 1. These things come across in our daily life. But there are few and more physical quantities which cannot be by heart. Okay, students, we cannot remember them such easily. There, this system will be useful. Okay, students, to convert one system of unit into another. In earlier class, we got the relation students. System of measurements, I told you. In system of measurements, I said Nu is equal to constant. Okay, students. Nu is equal to constant. What does it mean? N1, U1 is equal to N2, U2. Okay, students, N1, U1 is equal to N2, U2. Here, U1, U2 representing the unit of the physical quantity, and N1 and N2 are the, what's that, magnitudes. Okay, students. For example, you say one system of unit is taken as m to the power of a, n to the power of b, and t to the power of c. It is a physical quantity, students. It is neither in one system. It didn't show. We didn't show it in one system, in a particular system. It is a physical quantity. Say this physical quantity is q. And we say it is the equation. It is the q is the dimensional equation, and this one is the dimensional formula. I hope you understood. What is the difference between dimensional formula and dimensional equation? Okay, students. If you keep equal to, then the dimensional formula becomes to the dimensional equation. Okay, students. Here I am writing U1 as m. I am taking the subscript as 1 and power is same, L1 and T1 to the power of c. Similarly, students, U2 is written as m subscript 2 to the power of a, T2 to the power of c. Okay, students, and we are multiplying with the numerical value, the magnitude. Then we can write M1, N1, U1 as N1 of M1 to the power of A, L1 to the power of B, T1 to the power of C, and also N2, U2 is equal to. Okay, students, N2 to the power of M2 to the power of A, N2 to the power of B, T2 to the power of C. Now we are comparing these two, or equating. Then we can write it as N1, okay, multiplied with M1 to the power of A, L1 to the power of B, T1 to the power of C is obviously equal to N2 of M2 to the power of A, L2 to the power of B, and T2 to the power of C. This students, we can write this equation with respect to N1 and as well as N2. Okay, students, here I am writing with respect to N2. N2 can be written as what? N1 of M1 to the power of A, L1 to the power of B, T1 to the power of C, divided by M2 to the power of A, L2 to the power of B, T2 to the power of C. Okay? And it can also be written as L2 is equal to N1 of M1 by M2 to the power of A. Okay, student, into L1 by L2 to the power of B into T1 by T2 to the power of C. Okay, we have to use this formula to convert one system of unit into another, students. N2 is equal to N of M1, M2. Okay, students. By using this, now we are going to convert one system of unit into another. Listen to me, students. Energy. You know that energy is capacity to do work. Energy means capacity to do work. If you take the energy can be measured in erg joule. Energy can be measured in erg. Okay, unit of energy. Okay, students, what is the unit of energy? Erg in CGS system and joule in MK system, students. Okay, he's asking us how many erg makes a joule? How many ergs make a joule, or how many joules make a erg? That means what? We are converting MK system into CGS system, and CGS system into MKS student. CGS system into MKS system. Okay, students, here we are going to show 1 joule is equal to 10 power of 7 erg. And I will ask you, what is that? Find 1 joule is equal to how many erg? Okay, students, first we have to write the dimensional formula. What is the? It is the energy. Joule is the unit of energy. Dimensional formula of energy. Okay, students. As you know that energy is nothing but work. Work is equal to force multiplied with the displacement. Force is equal to Ma into S. Mass M1, L0, T0. Acceleration M0, L1, T inverse 2. And length M0, L1, T0. That means finally we'll get M1, L2, T inverse 2. Okay, students. M1, L2, T inverse 2. I'm writing in the standard form. I told you dimension equation Q is equal to M to the power of A, M to the power of B, and T to the power of C, where A, B, C are the powers. If you compare with this, you will get the power of mass is 1, power of length is 2, that is the dimension, and C is equal to minus 2. Okay, students. Then I am writing the standard form of equation. Right now we did that. N2 is equal to N1 of, what I write? M1 by M2 to the power of A, L1 by L2 to the power of B, T1 by T2 to the power of C. It is a basic equation, students. Now we'll write the units in CGS system and MK system. If you write the CGS, here in this one, all the physical quantities are involved. Okay. Mass is measured in gram. Know that. Mass is measured in gram. Length is in meter, that is centimeter. Time is in second. Similarly, if you go with the M case, mass is 1 kg. Okay, students. Length is 1 meter, and time, it is measured in second. As you know that 1 kilogram is equal to 1000 gram. Okay, students. 1 meter is equal to 100 centimeter. 1 second is equal to 1 second only. In all systems, the time is measured in second only. Okay, 1 kilogram, 1000 grams. Okay, students, now I am substituting all these values in this relation. Then N2 can be written as N2 is equal to N1, means what? M case we took 1 joule into, we are writing M1 with respect to what is the CGs, that is 1000 gram by 1 gram to the power of A. A is equal to how much is students? It is 1. Okay. Similarly, I am using the same relation. Length is measured as 100 by 1 L, that is B, it is 2. And third one, T1 means second by second. What are the dimensions there? -2. Okay, students? Then it can be written as N2 is equal to 1 half 10 cube into 10 square to the power of 2 and 1 to the power of -2. Okay, you cannot write it is equal to 1 only. Then you can write it is 1 half 10 cube into 10 to the power of 4. It is equal to 10 to the power of 7. What is N2? N2 is CGS system. We mentioned that. Let's say N1 and N2 previously. Okay, that means what? N2 is equal to 10 to the power of 7 arc. If N1 is MK system, it is 1 joule. Then N2 is 10 to the power of 7. Means what? 1 joule is equal to 10 to the power of 7 arc. Okay, students. In this way, you can convert one system of unit into another, students. Welcome back to Quest Edu Physics, students. In previous edition, we have learnt about how to convert one system of units into another. Actually, students, we are doing the dimensional analysis. In dimensional analysis, we can do different kinds of relations, and as well as we can check the equations and we can derive the equations also. But here, in this class, we are going to learn about principle of homogeneity. Principle of homogeneity. If you watch this sentence, you will understand principle is principle only, and homogeneity means what? Similarity. How we use the principle of homogeneity, we have to understand. Okay, students, everyone knows that birds of same feather sit together is a proverb, I think. Birds of same feather sit together. Understand, students? That means what? Similar people or similar thing can be added, can be subtracted, can be equated. Understood, students? Understanding me, what I am trying to tell. Similar things can be added, similar things can be similar. Strictly, I'm saying same things. Instead of similar, I'm using the same. Same type of things can be added, same kind of things can be subtracted, and same kind of things can be equated. The same sentence we are utilizing in principle of homogeneity. Same physical quantities can be added, same physical quantities can be subtracted, and same physical quantities can be equated. Okay, students, but there is no restriction of multiplication and the division of different physical quantities. See this, see the last statement. There is no restriction of multiplication or divisions, okay, with other physical quantities. But what it is saying us, same kind of physical quantities can be added, can be subtracted, can be equated. It is known as the principle of homogeneity, students, and the condition is that different kinds of physical quantities can be multiplied or can be divided. But while we are adding, subtracting, and equating, we have to, what's that? Add the similar. That means same, not similar, it's same. Then the statement can be written like this. What is the principle? Same kind of physical quantities. Note this, students, it is a very important one. Can be, number one, added, subtracted, and the third one, equated. And there is no restriction for division and multiplication of physical quantities. Okay, students, it is stating us that same kind of physical quantities can be added, can be subtracted, and equated, and there is no restriction for division and multiplication of physical quantities. We can understand this thing very easily, students. We have different physical quantities. It is given like this. Okay, force is given, work is given, okay, energy is given, pressure is given, and as well as velocity. Okay, this represents different physical quantities, students. Force is a physical quantity and work is another physical quantity. We should not add force with the work. It's the wrong way. You cannot add force with the work, or You cannot add, it is example 1. The second, you cannot subtract force from pressure. It is wrong. And the third example, you cannot equate work with the velocity or pressure with the velocity. Okay, students. Here it is the principle of homogeneity. Force, here what you have to do? Force can be added with the force. Force can be added with the force. It's right. That means what? Force can be added with the weight. Is that right? Force can be added with the tension. It is right. Okay. Then what can be added with energy? Because both are same. It's right. Force can be subtracted from the force. It is right. Force can be equated with the force. Understanding, students? It is the principle of homogeneity. Only same kind of physical quantities can be added, can be subtracted and equated. But you cannot add different physical quantities with each other. I mean, x have to be added with the x only. You can't count x and marbles together, even though they look the same. Understanding, students? Similar physical quantities can be added, can be subtracted, can be equated. But there is no restriction of division or multiplication of the physical quantities. Pressure can be multiplied with the volume. It's okay. Pressure can be multiplied with the volume. It's right. Okay, students. Pressure can be divided with velocity. It's okay. But pressure cannot be added with the volume. Okay, students. Pressure cannot be subtracted from the volume. And pressure cannot be equated with the volume. Okay, students. Let's do one problem, students. Actually, the equation is written as like this. Van der Waals equation is given as P plus A by V squared multiplied with V minus B is equal to RT. Find the dimensions of A and B. It is a question, students. This question is asked for so many times in competitive examination, students. When we are studying the same question is asked in IIT students. But at the time, I am unable to solve this question, students. At the time, we have limited sources to understand the physics. We have the limited edition of the books. Nowadays you can get various publications in physics and a lot of information through the Google. When we are studying, we don't have any such facilities, students. Okay, students. Van der Waals equation is given as P plus A by V squared multiplied with V minus B is equal to RT. Find the dimensions of A and B. In this equation, he mentioned here P stands for pressure. P is pressure, students, in this equation. Getting me, students? And V is the volume. Don't mistake it as the velocity. Generally we do. V is velocity. Okay, students. Only two. And R. R, you know that it is a gas constant. And T is absolute temperature. Okay, students. These are the physical quantities which are involved in this Van der Waals equation. And he is asking us find the dimensions of A and B. Okay, students, I told you only same kind of physical quantities can be added or subtracted or equated. Okay, students. Let's do this problem, students. Here, already explained which physical quantities are involved in it. First, we are taking this part. Pressure plus a by v square is equal to constant. We are taking the principle of homogeneity, and it can be written as pressure is equal to a by v square, and it can be rewritten as a is equal to pv square. And we know that what is the P and what is the V. P is pressure. We are writing the dimensional formula of pressure. Pressure is equal to force upon area. And you know that force has the dimensional formula of M1 L1 T inverse 2. Area is L squared. Then we had M1 L inverse T inverse 2. It is for pressure, students. Okay, students, and volume. Volume is equal to L cube. I'm writing directly. Here is said it is the square of volume. That means L to the power of 6, students. Now we have to write the dimensions of it. A is equal to Pv squared. Pressure we got here M1 L inverse T inverse 2 multiplied with L to the power of 6, that is M1 L to the power of minus 6 for this students into T to the power of minus 2. Okay, these are the dimensions of A, students. We got A is equal to M1 L inverse 6 into T inverse 2. And the second part we are taking V minus B is equal to constant. Okay, and V is equal to B. Volume is equal to B. Means what? B is equal to L cube, that is M0 L cube T0. In this way, we got A as M1 L to the power of minus 6, T to the power of minus 2, and B is equal to M0, okay, L cube, T0. It is the principle of homogeneity, students. I hope you understand. There is no need of using R and T, okay, in this equation. We are not at all equating. Without equating only, we found the values of A and as well as the B. It is the beauty of the principle of homogeneity, students. Then what is telling us that only the same physical quantities can be added. Means what? Immediately after watching this equation, you would understand that A by B square has the same dimensions of P, pressure. In the same way, B is equal to B. It can be subtracted. Okay, students. Let's go into one more problem. And these equations, what we are going to do now, are studied in 9th class, students. Okay. Here, the same thing can be applied for the, checking the correctness of equations. Checking the correctness of equations. Okay, students. Here, what we have to say, checking the correctness of equations. Okay, students. The basic equation I am taking here, students, that is V is equal to U plus AT. V is equal to U plus AT. This is the equation of motion, students. As you know that here, V and U both stands for velocity. And you know that velocity is displacement upon time. And A is acceleration, rate of change of velocity. Okay, students. And T is per time. Okay, students. Here, the dimensional formula, we have to write the dimensional formula of u and v, because both are velocities only. Here v is the final velocity and u is the initial velocity. Know that velocity is equal to displacement upon time. Okay, students, displacement is L by T, that is m0, L1, T inverse, and we had acceleration. Acceleration is what, students? Acceleration. Okay, we show with small a is the velocity upon time. Okay, students, already we got the velocity, dimensional formula of velocity, m0, L1, T inverse divided by T, that is m0, L1, T inverse 2. Okay, students, now we are substituting the values and time. You know that time T is equal to what we have, m0, L0, T1. Okay, we have to equate them. We have to show v is equal to u plus at. What we got? Velocity m0, L1, T inverse is equal to u, means m0, L1, T inverse plus a, m0, k, L1, T inverse 2 multiplied with time, that is m0, L0, T1. So finally, it can be written as m0, L1, T inverse is equal to m0, L1, T inverse plus m0, L1, T inverse 2 plus 1. Means what? m0, L1, T minus 1 is equal to m0, L1, T inverse plus m0, L1, T inverse. It might be 2 into m0, L1, T inverse. Numbers don't have any meaning in dimensional analysis, students. Finally, we can write m0, L1, T inverse is equal to m0, L1, T inverse. That's why, okay, both are same. LHS is equal to RHS. Okay, it tells us that this equation, V is equal to U plus AT, is dimensionally correct, students. Let's do one more. Okay, students, the next problem is asking us check the correctness of the equation K is equal to half m square. K means kinetic energy, students. Kinetic energy. What is kinetic energy? Energy possessed by a body by virtue of its motion, students. Energy possessed by a body by virtue of its motion. Kinetic energy, potential energy, whatever the energy is, all the energies are nothing but work done. And you know that the dimensional formula of work done is equal to what? Or kinetic energy or potential energy. It is force multiplied with the displacement. That is m1, L1, T inverse 2 into displacement is L. That is m1, L2, T inverse 2. Okay, students. We have to show it equal to half mv square. Numbers don't have any meaning in it. And we are writing the dimensional formula of mass. Another physical quantity I am taking. Okay, what it is? m1, L0, T0. Then after dimensional formula of velocity. V means velocity. Velocity is displacement upon time. That is m0, L1, T inverse. Okay, students? I said numbers don't have any value in that is you can write k is proportional to m v squared. Okay, proportionate constant, we are taking it as the one. The kinetic energy has the dimensional formula of m1 L2 T inverse 2 is equal to, for mass it is m1 L0 T0 multiplied with v square, square of the velocity, m0 L1 T inverse squared. It can be written as m1 L0 T0 multiplied with m L square T inverse 2. Then the bases are same. We have to add the powers. Okay, students, it is m0 only. Okay, that is m1 plus 0, L0 plus 2, and T0 minus 2. That is m1 L inverse 2, T inverse 2. See, the same thing is yielded here. That is what, students? LHS is equal to RHS. Hence, dimensionally, this equation k is equal to half mv squared is dimensionally right, students. It is about the principle of homogeneity and checking the correctness of equation, students. We have a number of equations in physics. Take a dozen of half of dimensions of such equations and try to check the correctness whether they are right or not by using the principle of homogeneity, students. And one more thing, you can see 3 videos in units and dimensions, same topic, on my YouTube channel, students. It is Quest Shadow Physics. If you like the video, please subscribe my channel to get the notification, students. Thank you for watching Quest Shadow Physics, students. Let's do one more application of the dimensional analysis, students. Let's do one more application of dimensional analysis, students. In this application, we'll find the relation between different physical quantities, students. Or indirectly, we can say, we can derive the formulas. If you know in a formula which physical quantities are involved, by considering those physical quantities, we can derive one expression. Such a question is written on the board, students. What he's saying, deriving an expression for the centripetal force F acting on a particle of mass small m moving with a velocity v in a circle of radius r. Okay, students, maybe most of you are familiar with the centripetal force. We call it as the center-seeking force. When it develops, when a body is rotating in a circular path, okay, it is rotating in a circular path. I'm not saying revolving. It is rotating in a circular path. Here, a force will act which tries to take that body towards the center. That is known as the centripetal force. And the centripetal force depends upon the 3 factors we said. One is the mass of the body, and second is the velocity with which it is revolving, and third is the radius. Okay, by using these 3 parameters, we have to derive an expression. Okay, students, it is small. I am taking it as small. Let's do the solution. I said in a circle, if the particle is rotating or a body is rotating, a force will develop. Okay, let's say it is the mass moving with the velocity of v bar. Here it is a revolving radius. A force will generate. It works towards the center. We call it as the centripetal force. You must remember that the particle has to move in anti-clockwise direction. Okay, students, if it is the anti-clockwise direction, then what will happen? Every time the angle will increase. Let's say These physical quantities are related like this. Say, force is proportional to. We are taking three physical quantities. One is the m, second is the velocity, and third is the radius. If you write a dimensional formula, all the time we'll get the powers to the physical quantities. Let's say m to the power of a, b to the power of b, and r to the power of c. Okay, students. Now we are writing the dimensional formula of force. Know that force is equal to m1 L1 T inverse 2. Okay, students. And also for the mass, the dimensional formula is m1 L0 T0. For the velocity, it is m0 L1 T inverse. For the radius, that's the distance, m0 L1 T0. Okay, students, these are the things what we need. Right now, I'm writing the values here. Is the V and it is the R. Here we got a relation. F is proportional to m to the power of A, V to the power of B, and T to the power of C. Okay, students. R to the power of C. R to the power of C, students. Okay, students. Then see, we know the dimensional formula of force, mass, velocity, and also radius. I'm rewriting the same here. I'm writing force is proportional. In the place of proportional, I am writing it is the K, proportionate constant. M, mass. What is the dimensional formula of mass? It is m1 L0 T0 to the power of E. And for velocity, it is m0 L1 T to the power of inverse power B. For the radius, it is the length, students, m0 L1 T0 to the power of C. Further, it can be written as F is equal to K of m to the power of A, L to the power of 0, T to the power of 0 multiplied with m to the power of 0, L to the power of B, T to the power of minus B. And third, m0, L to the power of C, and T to the power of 0. Okay, further it can be written as K of. We are taking the same physical quantities. If the bases are same, we have to add the powers. M to the power of A plus 0 plus 0, okay, into L to the power of 0 plus B plus C, and T to the power of 0 minus B plus 0. And finally we get K of m to the power of A, L to the power of B plus C, and T to the power of minus B. Okay, students, up to here we did everything. Now we are comparing this equation with the equation of the, what's that, dimensional formula of the force. As you know that dimensional formula of the force is m1 L1 T inverse 2 is equal to K of m to the power of A, L to the power of B plus C, and T to the power of minus B. We are comparing the power, students. You can write A as 1, B plus C is equal to 1, and minus b is equal to minus 2. Okay, students. Then we got minus minus get cancelled. And finally we had b is equal to 2. Okay. We had the values of a, b plus c and b. Okay, we have to get the value of the c. Substituting this b in this one. B plus c is equal to 1 and b is 2. 2 plus c is equal to 1. C is equal to 1 minus 2. It is minus 1. Okay, students. And we had a as 1, b as 2, and c as minus 1. Now we are substituting all these values in the given relation, this one. Okay, we have to write it as f is proportional to m to the power of a. Means m to the power of a means 1. And second is b to the power of b. b is equal to 2. Okay, students. And r to the power of c. c is equal to minus 1. Or you can write f is proportional to m to the power of 1 b square by r. Okay, students, m to the power of 1 is m is proportional to m v square by r. R f is equal to k into m v square by r. K is taken as 1. Then centripetal force has a dimensional formula of mv square by r. Okay. In this way, you can derive a dimensional formula. Sorry, derive a formula by using the dimension analysis. Okay, students, it is one of the applications of dimensional analysis. If you know the physical quantities which are involved in any formula, then you can derive the formula easily. Okay, students. Let's do one more relation, students. Here in this question he asked us, we have to derive this expression. That means what? Frequency is equal to 1 by 2L into root of f by m. Okay. And these words have their usual meaning, students. Nu is frequency. Nu is what? Frequency. What is frequency? You have to understand, students. Frequency is nothing but number of vibrations made by a body in 1 second. Number of vibrations made by a body in 1 second. But generally we can write it as reciprocal of time period. Reciprocal of time period. That is frequency nu is equal to 1 by t. And its unit is what? 1 by second. Means second inverse. Okay, students. It is the frequency. Then second is said depends upon the load. Load means force. The second one is load. That is force. As you know that dimensional formula of force, and you know that force is equal to ma, or the dimensional formula can be written as m1 L1 T inverse 2. Okay, students. And one more physical quantity is involved. That is length of the spring. That is length of the spring. Length of spring is L. Okay. And dimensional formula of length is equal to m0 L1 T0. And one more thing is involved here. He said that mass per unit length. Mass per unit length is known as linear density, students. Mass per unit length is known as linear density. Linear density means what? Linear density is mass upon unit length. Okay, students, if you say linear density is x, it is mass per length. and the dimensional formula. Okay, students, is equal to m1 L inverse T0. Okay. Okay, students, here we have the dimensional formula of linear density is this. Okay, I'm taking linear density as small. That's why we use the m here. Then the relation can be written as frequency is directly proportional to. First term, I'm taking force to the power of A. The second term, I'm taking length to the power of B. And third is the linear density. Linear density. Remember that. M to the power of C. Okay, students. Then it can be written as frequency is directly proportional to. I'm writing the dimensional formula of force. What is that? M1, L1, T to the power of minus 2 to the power of A. Then directly I'm writing A to the power of B. And linear density we have M1, L inverse T0 to the power of C. Okay, students, then it can be written as N is proportional M to the power of A, L to the power of B, T to the power of minus 2A multiplied with length to the power of B and M to the power of C, L to the power of minus C and T to the power of 0. When the bases are same, we have to add the powers. Frequency is directly proportional to M to the power of A plus C, L to the power of B minus C and T to the power of minus 2A. Okay, students. Here, we learn that frequency is reciprocal of the time and its dimensional formula of frequency is equal to T inverse. T inverse. Further, we are writing this as N is proportional to M to the power of 1 means M to the power of A, L to the power of A, T to the power of minus 2A into L to the power of B multiplied with M to the power of C, L to the power of minus C. I'm neglecting the T. Then M to the power of A plus C, L to the power of A plus B minus C, T to the power of minus 2. Okay, students, but frequency here is T to the power of minus 1. That means we can write M to the power of 0, L to the power of 0, T inverse. Then after we have to compare the powers of these physical quantities. From this we can write A plus C is equal to 0. Okay, then A plus B minus C, A plus B minus C is equal to 0 and minus 1 minus 2A is equal to minus 1. Okay, and it can be written as 2A is equal to 1 and A is equal to 1 by 2. We have the value of A is equal to 1 by 2. Here I am substituting. A plus C is equal to 0. In this one, A is equal to 1 by 2 plus C is equal to 0 and C is equal to 1 by 2. That is minus 1 by 2. Similarly, if you substitute all this in this one, you will get B value. That is A plus B minus C is equal to 0. It gives you A is equal to how much? 1 by 2. Okay, B is equal to, we have to find, and C is equal to minus half. C is equal to minus half. That is minus of minus 1 by 2 is equal to 0. And finally we get 1 by 2 plus B plus half is equal to 0, then B is equal to 1. And we can write the powers as A. Okay, students, we had A is equal to 1 by 2. Okay, C is equal to minus 1 by 2. And we need to find the value of the D. Here we got B plus 1 is equal to 0 and B is equal to minus 1. Okay, students, now we have to substitute all this in this relation. That is, nu is proportional to F force to the power of half. Okay, students, L to the power of minus 1 and M has a power of minus half. Okay, students, and it can be written as F is proportional L inverse into F to the power of half by M to the power of half. I brought it down. Then it can be written as nu is proportional to L inverse can be written as 1 by L. Okay, students, 1 by L I am writing in the root F by M. Okay, students, if you take the proportionate constant as 1 by 2 and we yield the equation 1 by 2L into root of T by M. It is the actual form of the equation. Here force, he said, force is the load. This load is known as tension, students. Tension is also a force. That's why finally we got the equation. Frequency of a vibrating string is 1 by 2L into root of T by M. I hope you understood this problem.